Hello, everybody. Thank you for being here. And please join me to welcome Luca Arrotta, Head of AI of Data Pizza. Big round of applause. Thank you. Okay, we talk about AI agents and best practice for this. Thank you, Luca.
Thank you.
The stage is yours.
Thank you. Hi, everyone. It's a pleasure to be here. And how many of you know Data Pizza? OK, great, nice. And maybe you know Data Pizza for our social media channels and so on. But actually, 1 year and a half ago, more or less, we built an R&D team focused on Gen AI technologies. And so the goal of this talk is to share some knowledge about what we have learned by doing R&D and building projects based on this technology. And I think that it's very important to share this knowledge, and we'll see some lessons that we have learned. This is the agenda. We will see, just that everyone will be aligned, the difference between a large language model and AI agent. I'm sure that all of you know this. Then we will see which use cases can we consider when we build something based on AI agents. Then we'll see the difference between agentic workflows and workflow based on just LLM API calls. And then we'll see a sequence of best practices. So very shortly, all of you knows what is a large language model. So we have this AI model that has been trained on huge amounts of data. And we can have a problem by interacting with the large language model because it can answer to our queries just based on what it has learned during its training process. And so this limits our use cases because it's like talking with a colleague and asking something to this colleague, but your colleague can just answer based on his or her own knowledge, based on what he has learned. Okay, so this colleague cannot go on Google, cannot use a software of the company, cannot do an SQL query to retrieve some data that can be useful to answer to your query. And so these limit the kind of questions that we can do to an LLM and to this colleague. So just very easy, how to integrate an LLM in Python in our software. We just to make a simple API call. In this case, we use an OpenAI model. And we have to provide an ID for the model and then a list of messages, the conversation that the model is having with the user. And we typically have a developer or a system message where we provide the overall instructions of the conversation that the model has to follow. And then we have, in this case, the first query of the user. We receive, in response, a JSON object where we have the response of the assistant of the model. Now, what about AI agents? An AI agent basically is just an LLM that has a set of tools. And this LLM can use autonomously, will decide when and if it is necessary to use these tools during the whole conversation. And what is a tool? A tool can be actually anything that we can build by writing Python code in this case. Okay, so we can allow the agent to make SQL queries and retrieve data from a DB, to connect, interact with Google Maps to take directions between a starting point and a destination, and so on. And so in this case, it's more like talking with a colleague that can use these kind of tools. And so we can ask a harder question and a more complex task. How to do this in Python actually is very easy. We have to describe the tools that we want to provide to the agent. In this case, a very simple tool that allow the agent to get the current weather conditions in a location. And so here you can see that we need to describe in natural language how to use this tool, in this case, get the current weather in a given location, and then we have to define and describe the parameters that the agent have to provide when asking for this tool. And then we have the same API call as before. We just have to provide the list of tools to the LLM, and then there is the parameter tool choice, which typically if we want that the agent make decision autonomously, we just add the auto parameter. And in this case, the JSON response changes. In this case, in the JSON response, we have also this tool calls key, and the value is the list of tools that the agent wants to use to answer to the user. Okay? In this case, the agent is asking to the developer to use the getCurrentWeather function with the location parameter equals to Boston. Okay? And so what happens under the hood, this is very important, it's not the agent that will run the code, but the agent asks to the developer, and the developer under the hood will call the Python function that implemented that tool. And so under the hood, we have to take the system message. We can check if it asks us to run any tool call. We append this request from the agent in the messages, so in the conversation. And then for each tool that the agent wants to run, we actually run that tool. So if the agent asks to run the getCurrentWeather tool, we actually run the getCurrentWeather Python function that we have implemented. Okay? And then we add to the conversation the results of this function. And so next time that we will call the same agent with this new conversation, with this updated conversation, the agent will see that it asks to use a tool, and we provided the answer of that tool, the result of that tool in the conversation, and then the agent can use that result to answer the user. Okay, we have seen how to build a very simple agent, but it's very important to understand that, again, a tool can be everything that we can build by writing Python code in this case. And so a tool for an agent can be actually another agent that is specialized in another task. And so in this way, we can build very complex systems because we can build teams of AI agents that communicate and collaborate with each other to solve a complex task. And overall, we have seen two kinds of categories of use cases that we can solve by implementing multi-agent systems. We have cost optimization use cases and revenue accelerations ones. This is more a business slide, let's say. Typically, companies and developers focus on cost optimization use cases, if you think about it. Typically, if you think about Gen AI, you think about chatbots for customer service and so on. This is a typical use case for cost optimization. So you help operators, human operators, and you automate or semi-automate their process, their work process. Okay, in this case, for example, you can build a team of AI agents that collaborate to answer automatically to the emails of the customers of your client, of a company. Okay. A company, okay, are interested in this kind of use cases, and probably is the first idea that they have when you talk about Gen AI. But in this case, you're just optimizing costs. But companies typically are more interested in accelerate revenues, to increase the revenues. Okay, so I think, and in Data Pizza, we think that the most interesting use cases are those that are closer to the revenues. So you can build, for example, a team of AI agents that automatically build a report that the executives or the managers of a company will use to make decisions. And typically, humans, I don't know, require 2 weeks to build this report. And if you generate this report in 2 hours, you help a lot to the company to make decisions faster. And another use case, for example, is to provide, I don't know, a chatbot that supports the salesman of a company to increase and accelerate the sales cycle of the company. So you can build, you can accept quicker a request to buy a product for a customer, or you can build your quotation documents faster, and so on. So in this way, you accelerate the sales cycle of the company. Now, how to build these kind of solutions? Typically, when you talk with the customer, you always talk about AI agents. I agree with this, it's a very cool buzzword. So if you talk with one of your customers, always talk about AI agents, but it's not always, you don't always need an AI agent to solve a complex task. Typically, under the hood, you just have a sequence of API calls to LLMs, okay? And so actually, this is the main difference. There are different categories of workflows that you can implement, but typically you have these two categories. So workflows based on a sequence of predefined API calls to LLMs, okay? And then otherwise you actually build agents. And somehow you have a hybrid workflow actually, okay? So LLM workflows are perfect when you can understand, you can predict in advance which is the sequence of instructions that you need to run to solve that task. Okay, and so it's perfect for well-defined and repetitive tasks. For example, I don't know, you are a social media, so I don't know, a media company, you want every day to take a YouTube video, I don't know, in French, and from this YouTube video you want to build in parallel different posts for the different social media channels in English and Italian. How to do this? You don't need an agent or a team of agents to do that. Typically, okay, you can take the YouTube video. Whoops. Oh, okay. Just dark, I think. Yeah, yeah. No, it's the slide. Well, it's not a good slide, okay. Thank you for your feedback. Thank you for the feedback. Don't worry, don't worry. So you started from a YouTube video in French. The first thing to do, okay, you call a Python function, and for the first time, the first thing to do is, okay, let's call an AI model that generated a transcript from the video. Okay, this is the first step that you need to implement. Then you have to, I don't know, identify key points from the transcript. Then you can generate a synthesis. And then in parallel, from the synthesis, you can translate the French synthesis in English and then in Italian. These are all API calls that go in a sequence, in parallel, and so on. But the sequence is predefined, as you can see. Then from both translations, you can optimize the translation based on the tone of voice of the company, and then you can actually generate the posts. Everything is predefined. Then the single outputs of the model are probabilistic, as you know, but the sequence of instructions is predefined. And so every time that you need to create these 6 posts, you just have to run always the same sequence of instructions. Agentic workflows are different because in these cases, you don't know, they are perfect when you don't know, you cannot know in advance which will be the steps that you need to solve the query of the user. Okay, so you need something intelligent that make decisions for you in real time based on the conversation that it has with the user. In this case, this intelligent entity is an agent, so an LLM with tools. Okay, let's do an example. For example, you want to simulate a data science team, for instance. So you have, I don't know, a chatbot and a user that can interact with the tech lead of this data science team. This tech lead can be an agent. So this can be the system prompt. You are a tech lead with 10 years of experience. And one of the tools of this tech lead could be another agent, which is a data engineer agent. So for the tech lead, we define, I don't know if you can see the code. Okay. And for the tech lead, you can define the data engineer as a tool, and the description of this tool is ask a data engineer to preprocess a data set provided by the user. So this is one of the tools of the tech lead. So the data engineer, as I said, is another agent, and so the system prompt could be you are a data engineer with 10 years of experience. And among the tools of the data engineer, we can provide a code interpreter so that this data engineer can write Python code to preprocess the data set and then run this code thanks to the tool code interpreter, receive the output, see the output, and fix the bugs in the code and so on. And as you can see here, we can have a loop. We don't know how many times the data engineer has to fix the bugs in the code or so on, or maybe the data engineer tries to import the data set, but the path provided by the user is wrong, and so the data engineer should ask to the tech lead to ask the user to provide the correct path for the data set, and so here we create a loop between data engineer, tech lead, and user. We cannot know in advance how to handle this tool deterministically. Okay, so we need something that makes decision autonomously. Then the tech lead can receive the preprocessed data set from the data engineer and provide it to the data scientist and data analyst through other tools of the tech lead, but these tools are actually through other agents that then can I don't know, train a machine learning model on the data and generate plots based on the data set, okay? And at the end of the talk, we will see a short demo of this team of AI agents that collaborate to analyze a data set, okay? Now, I think the most important part, let's see some lessons that we have learned by building projects based on Gen AI. The first suggestion is very easy, quite obvious. Start simple. So the first thing that you should do is to build a first working solution that is the simplest one. So don't start building a team of 20 agents that has to communicate. It will be very hard to debug them and to understand where is the problem among these 20 agents. You should start from the simplest solution that you have in mind, and then you can understand where are the problems. So you can see, I don't know, the second agent that you created has to do too many things, and so you can split the task of this agent in subtasks, and so you can create other tools and handle those subtasks with other tools, other agents, and so on. So start simple and then increase the complexity of your solution only when needed, because in this case, it will be easier to debug the solution. I don't know if you are a novice in this field. Maybe, I don't know, you are a developer that wants to knows more about Gen AI. My suggestion is don't start with the frameworks. Don't start building project with LangChain or Llama Index and so on. It's the best thing to do is starting from scratch. You have seen that the code is very easy, actually, to build an agent and so on. And if you start using LangChain, these frameworks are OK for proof of concepts, and that's OK, but they add syntax, they add levels of abstraction that covers what happens under the hood, and so if you are a novice, you don't know what is happening under the hood, and you don't know how to solve the problem if you have bugs, for example, and so on. And then they add also constraints. For example, if OpenAI release a new feature, so you have to wait until they add it to the framework. It's typically is complex, or sometimes it's complex to build custom components that you need for your solution, or sometimes you have errors from LangChain, and so it's harder to debug errors that are not yours. And in general, so you have less control. If you have to build something that needs to go into production, it's much easier if it's something that you have built, okay, and on which you have control. This is a very nice suggestion, I think. Building projects based on prompts, it's a fucking nightmare for a developer. You change a single word in the prompt and everything change. So how to debug prompting? We typically use this trick. We add the tool to the agent. For example, here, I call the tool print toads. And the description of the tool is for the agent. Use this tool to log your toads before giving an answer or using a tool. So in this way, we can debug and log the thoughts of the agent, and so we understand if in our prompt there is something ambiguous. In this way, we understood, for example, that there was something, there was some knowledge that for us was implicit, but it was not for the agent, and so we had to add some information in the prompt. Everything thanks to this very simple tool. Of course, this not ensure that you know actually the thoughts of the LLMs, because I don't know if you read the report from Anthropic of the last month about the biology of large language models. Sometimes their thoughts, when you ask them to provide an explanation for what they do, they make, sometimes they trick you, okay? So you cannot you cannot be 100% sure about the thoughts of the agent, but typically this works for remove ambiguity from your prompts, okay? Also, this suggestion is quite obvious about, I hate the word prompt engineering, but actually just to remember you that the descriptions of the tools are actually prompts that under the hood will be part of the system prompt of the LLM. So when you implement a tool like here, the description in natural language is must be not ambiguous because it will be part of the system prompt of the agent. And so maybe for complex tools, you have also to add some usage examples, edge cases, and so on. About evaluation, this is the hardest part of a Gen AI project, typically. From the beginning, you should focus on designing with the human expert, human domain expert, an evaluation dataset and some evaluation metrics to understand how well your solution is going. And okay, you define this evaluation dataset. It is very hard to define it and to design it with the human experts. And then, typically during the developments, you will have a lot of ideas to solve the task. And if you have 10 ideas, you cannot provide all the answers from your system for these 10 ideas and then ask to the human expert to give you feedback. So typically, it's a good choice to implement also a solution based on LLM as a judge. So you can use an LLM to mimic how the human domain expert will score the outputs of your system. And then in this way, you can partially automate the evaluation process. If you have 10 ideas to experiment, you can discard the 8 worst ideas thanks to LLM as a judge, and then you can ask feedback just for the 2 best ideas from the human evaluators. Okay. And in the end, you will always need the humans to obtain qualitative feedback, and based on this qualitative feedback, you can understand that you should categorize the problems that you have, and then to update your roadmap of experiments, your roadmap of ideas that you want to test, to check if they can solve some of these issues. And another thing about evaluation is that among the metrics, you should have also latency and cost, of course. And these are very binded with AI agents. About latency, for example, an agent can wrongly use a tool because it will use repeatedly this tool, and so maybe this means that you have to provide a better description for that tool. Okay. Another problem that we faced a lot of time, we always had in our project a feature for a feedback feature like thumb up and thumb down, but users don't provide feedback actually, even if you provide this feature, and so it's very important to analyze offline the conversation of the users with your chatbot, because in this way you can extract insight and implicit feedback from the user behavior. For example, if you see that for a lot of conversations, your users seem frustrated, or maybe there are a lot of follow-up questions for the users. Maybe it means that your chatbot or your agent, the answers of your agent are too unclear, I don't know, and so you have to improve prompts or to improve the knowledge binded to the agent. Or your solution cannot answer to a lot of questions, so maybe you have to extend the capabilities. Another best practice, let's say, is that we understood that with Gen AI, one size does not fit all. So it's very hard to build a solution that works well for a domain, and then to get this solution, copy and paste it into another domain for another customer, and just works. It doesn't work, actually. With Gen AI, you have I think always, to customize your solution based on the domain, based on the data, based on the goals expected by the customer, and so on. You cannot. So it's very hard to build products that are plug and play with Gen AI technology. About, again, the use cases that we have seen before, about cost optimization or revenue accelerations, as I already said before, actually, if you have to decide, okay, I want to start from this use case, it's better to focus on revenue acceleration use cases. Why? First of all, they are closer to the revenues, and so they are easier to sell. And the second thing is to facilitate your delivery, because typically revenue acceleration use cases are, in the end, for example, a chatbot used from the salesman of the company. And so this means that this chatbot will be used internally by the company. And so you have less edge cases to handle intuitively, because, for example, you can train those salesmen telling them, for example, okay, you cannot attach to your query a very low quality image because our solution cannot handle it very well, so don't do this. Otherwise, if your chatbot is for external use, you have to solve and consider a lot of issues, a lot of edge cases that could happen, because you cannot train the end users, okay? So it's easier to sell and easier to implement a revenue acceleration use case. And the last best practice is about UX UI, actually. In our solution, we always add this kind of feature. I can show you. This is a classical chatbot. In this case, we don't have agents under the hood. Actually, it's a RAG. But we always add, this is an example of conversation. Here under the hood, there are different documents. This is a document from Poste Italiane, a very huge PDF from Poste Italiane about the speed, how to create the speed, so it was a nightmare, if you remember. And in this case, we ask, okay, translate in English a table, the abbreviation table about the speed process. This is the answer, okay, nothing special. But we always add this feature. So we want that the user can, in one click, in a few seconds, can check if the answer is correct or not. Because you know that the models can hallucinate, so this can be a real pain. And so we need to increase the trust of the user in the usage of our tool. And so, for example, here you have the sources. In this case, I know this is the third one. We have to improve this feature. And in one click, you can see in the PDF, the original PDF, we highlight the part of the file that the model used to answer the query, okay? And so this is so important, this feature, because otherwise the operators that will use this tool should check manually if the answer is correct, especially in the beginning, in the first iterations that he has or she has. And so it will be a pain, and the tool will be not used because the operator cannot trust it. Okay. Another example, this can be made for all types of format. In this case, it was a table in a PDF, but it could be also an image. In this case, I ask, okay, when the Aka Pizza took place, this was an hackathon that we organized some months ago. And in this case, the information was in a picture inside the PDF, and so we can also highlight pictures. You can do, and in the picture, you can see that here are the dates, okay? And this can be done also with video. You should implement this feature for all kind of formats, actually. And you can do it thanks to multimodal models and so on. The last thing that I want to show you is an example of a team of agents that collaborate to analyze a data set. Of course, this is a toy example. Let's see if we can follow the logs. Okay, here we are. We are the user. We ask to analyze the Titanic dataset because it's a toy example. Now we are invoking the tech lead. The tech lead, you can see, is invoking the data engineer. The data engineer now is writing some code to preprocess the dataset. This is also just a little bit slowed down. The data engineer is writing code, use the code interpreter to receive feedback, resolve bugs, and so on. Now, the data engineer, if you see at the top, the data engineer ends the execution because it actually cleaned the data set. And now the tech lead is invoking in parallel the data analyst and the data scientist. And now the data analyst and the data scientist will write code to generate some plots and to train a machine learning model. Now we should see some plots that will appear. These are plots generated by the data analyst by writing Python code. Under the hood, now the data scientist is training a machine learning model. This is a classification report for a random forest classifier, as you can see. Now, if I go at the end, here we have a final report provided by the tech lead to the end user. Okay, so this is just a basic example to show the potentialities of creating a team of AI agents that collaborate. Okay, and of course, actually, typically you have hybrid workflows. As I said before, typically you have some predefined sequence of operations that you have to do, some predefined steps, and sometimes you have a step that to be solved, has to be solved thanks to a team of AI agents that collaborate autonomously. And another thing that you can do here, for example, the data engineer has to preprocess the data set, but it makes fully autonomously its own decisions, but you can add a feedback loop, or you can say to the data engineer just in the prompt, whenever you want to, I don't know, drop a column, ask to the user if it's a good idea, and only if the user accepts your idea, you can then implement this preprocessing step. Okay, that's it by my side. Hope it was useful. Thank you. I don't know if you have time for questions.
Yes, for sure. Thank you, Luca. Big applause for Luca. You did already. And
Thank you.
any questions?
Over there.
Oop.
Hi, thanks for the great talk. I have a question about the one size does not fit all thing you mentioned. I totally agree with that right now. I'm wondering, and it's a question that often comes, how long will that stand? Because obviously the big players, starting from OpenAI, Anthropic, Mistral, and everything, that's what they are challenging, right? They try to convince everybody that that's what's going to happen. So which space is left for us in the future? And with us, I mean smaller players playing on the one size does not fit all argument.
That's a great question. I think that overall, I don't know, ChatGPT, for example, is a general purpose solution that at the moment should work for every kind of company, of course, and so this is why nowadays it cannot be a one-size-fits-all, because if it has to work for every kind of domain, it shouldn't work very, very good in the specific domain of the company. And I think that it's very likely that maybe there are a lot of use cases that nowadays you need to solve by customization, then will be solved. For example, I don't know, maybe when a company needed to connect ChatGPT to GitHub, and now it is possible, I don't know. But I don't know if that company has a proprietary software, it's very hard that ChatGPT can solve that. Maybe you need a developer that connect somehow ChatGPT to that software. Now it's more complicated, and maybe you have to create your own solution that connect to that software. But in the future, I think maybe this integration will be easier and will require less time to the developer, because now the integration requires a brand new software that create the integration. But I don't know, thanks to MCP server, maybe in the future you just have to create an MCP server that you can attach to ChatGPT to connect to the proprietary software of the company. So I think that customization will be always in the game, but it will be probably easier in the future. And so the space left to the developers will be smaller, probably.
We have 3 more minutes. Any questions here? Okay.
So thank you again for the talk.
Thank you.
I have a question about complexity. I mean, behind the great possibilities and performances that we can achieve with these kind of systems, there is, of course, a lot of codes to LLMs and a lot of more codes, I think, if you think about security. Now you have to insert control layers and so on.
Yeah.
So how do you manage the costs of these solutions, and when the use of these agents is justified for the application?
Great question.
How do you
Thanks.
evaluate this?
Yeah, typically, first of all, sometimes you have a use case when you just tell to your customer, okay, we can do that. Probably it will be very costly, very expensive. Maybe for each query you need to pay $1. But in 6 months, this $1 will be decreased, because we have seen that we have bigger and bigger models, more intelligent models over time at a lower cost. So the cost in general will decrease overall. And how to solve this now? It's typically by splitting down the task in the right subtasks. So if you can split a very complex task for which you need a very intelligent model in 2 subtasks where you just can use 2 more efficient and more economic models, then you just, in this way, this is a way that we use to decrease the cost of the solution. So these are the 2 reasons that I see.
Okay, thank you very much. We have no more time. I'm
you.
sorry about this. Thank you, Luca.
Thank you.